That much said, thank you very much, Monsieur. C'est à vous.
So, vielen Dank für diese Vorstellung. So, good evening. We are trying to survive with all the different problems with technology and make all the demo. There is only one demo that it will be not possible to do, but we will put all the technical details on the website alongside with the slide. So, I'm Eric and here Paul. We have worked on security or insecurity of mobile banking, and we are going to present a few results about what we have found. So here is the table, the agenda of this presentation. So I will first introduce the background. In fact, all these studies have been performed during the DEFI project. I will present this project. And then Paul will explain the different tool he has developed to perform static analysis, to collect different APK, and to perform the dynamic analysis. Then we will switch to the results. First, I will give some statistics about the different apps we have analyzed, and Paul will present 4 cases which are rather illustrative of what we have found. And you will see that, especially for the first one, very surprising things can be found. And then I will conclude. So, in fact, the DAFI project, it was a 2-year project to develop a sovereign and trusted AV for Android platform, Linux platform, and Windows. Not for Apple, because the French government was not interested in Apple. Too much Big Brother. And it has been funded partly by the French government, in fact, the Prime Minister office, in the context of the digital plan for sovereignty. The grant total was about 6 million euro, and on the government has funded only 35%. So, as a research lab, we have produced the proof of concept, and then we have delivered the product, and as well as the intellectual property to a society who is in charge of the marketing. And the name is no longer DAFI, because DAFI was a project, and is Ouro Mobile, and for the mobile Android platform, and Ouro Anti-Malware for Linux and Windows. Normally, it was in the timetable. Normally, free and open versions should be released, at least for non-commercial use. I hope they will do it. But at the lab, we have decided to work on a fork version, and for Linux at least. And normally, by mid-March, we should release everything, including the source code. And the name will be OpenDAFI Linux. But if you want more information, please refer to the official webpage of the project. So, if we focus on the DAFI Android platform, in fact, we have delivered the product 1 year ahead of the schedule, and so in October 2013. It was based on Cyanogen and IOSP sources. In fact, from the beginning, it was clear that implementing another antivirus application will be a failure, because if you go deeper into the system, you can get rid of the application. So, in fact, we decided to build a complete anti-malware operating system. So we rewrite the Android system based on these 2 sources, and we have added some additional security features, like total file system encryption, SMS encryption, VoIP encryption, and especially an application market accepting only secure and analyzed, certified, and digitally signed applications. So that's why we decided to analyze a lot of applications, including banking applications. So all those apps are analyzed, static analysis, dynamic analysis, and Paul will present the different techniques. And of course, we are going until the production of the source code by reversing step. And we have defined, of course, a security policy, a trust policy, I'm going to present right after. And if it is not a malware if the application does not contain any malicious feature and is compliant to this security policy. Then the application is certified and is digitally signed and put on the market. And for the different feature, please refer to the official website of an IT company. So, the trust policy. In fact, if you just consider that whether the apps is a malware or not, it's not sufficient. Because between malware and very safe application, you can have a lot of things. Non-desirable property, and especially regarding data confidentiality and users' privacy, which is a big problem. So in fact, the malware, what is malicious, must be extended to something a little bit broader than simple malware functions. And in fact, we have defined a trust policy. An application is trustworthy if, of course, it is not a malware. It is a minimum, but it does not contain hidden functionalities. No information is collected unless it is strictly necessary for the application. And every communication between the application and the remote server must be encrypted. And of course, there is no vulnerabilities. So why did we focus on banking applications? But in fact, banks are forcing us to use more and more tablets and smartphones in order to connect to our bank account. And more, the conventional banks will disappear. So it is our money. Banking application give direct access to our money and all the data about what we have purchased and so on. So of course, it's a critical issue. And for example, as a user, I don't want that my bank has too much or too many information about what I am doing. And of course, any external attacker. So, and the other aspect, since banks have much money, normally they are supposed to do a clean job, perfect job, and they should normally release only very secure and safe application. So we have contacted all the banks in order to alert them about the problem we have found, and everything that was free. But up to now, only a few of banks have answered and asked for more details. Only 2 in France have asked for the technical details and are currently correcting the part regarding vulnerabilities. I'm not sure that we will do it for users' privacy, but it's another problem. We will check, however. So
I make 3 tools. One for antivirus and static analysis called Agile. A second one for web crawling of web application to find wild malwares. And the third one for dynamic analysis, in fact, network communication monitoring. And I started with 1,800 applications, both malware and genuine. And these tools are not present, are not open source at the time. So the goal of Agile is to detect malware based on similarity with known malwares. The main hypothesis is that there is no common, not necessarily common characteristics that defines, that characterize all malware. It's why the traditional way of detecting malware is to splitting them into families of malware. It's these families that share common characteristics. So if we could do some sort of statistics on these families, and we compare them to the statistics from a genuine application, we could reveal these common characteristics. Ouais. Agid can also produce static analysis report for manual analysis. I will show you it. Sorry, there was a demonstration between, but because of the bugs at the beginning, I could not show you it. So it
will be on the website.
Yeah.
So you will find all the missing information.
When I scan an application with Agid, it basically reversed it to an equivalent of source code, and it extracts lots of characteristics like permission, file digest, class and method's name, entry point method, known behavior from malware, something like that. And all this information are used to make similarity scores to compare an app with a malware family. Okay, this is the demonstration I could not show you, but I explain you quickly. So this report summarizes some of this extracted data. Tu peux remettre juste au début, s'il te plaît. This report summarizes some of this extracted data to help a manual analysis. So we get basic data like permission, but more important one like risky behaviors. We can see there it's not translated because it's for internal use, so it's in French. Sorry, and the table of risky Android API call. So these risky calls are seen 2 times more in malware than in a genuine application. It's why it's nice to see where they are used in the code. So when I click on, for example, location service, which is a known behavior detected, I can see where on the code it is used. And when I click on one of these functions, I can see the reversed code. So it's a sort of a guide for manual analyzing, a starting point.
So sorry for the format, but
it's Windows. Because
normally it was we should do it on Linux, but Windows has some.
Windows is plug and play, but can print text correctly.
Because we have a direct link between the report and the source code, and it is possible then to check whether it is a genuine call, a non-dangerous call, or a malware code. So we have the link, a constant link between the report and the source code.
Okay, let's carry on. So let's carry on. Yeah, it's a messy start. Sorry for this. So let's go on. Yeah, there.
You pass?
No. The antivirus worked pretty well, but not as I expected. And the reason was the database of malware application was too small for being serious in the antivirus game. So I designed a massive web crawler called Tarantula to download lots of applications and hoping they were malware. So in reality, this subject is of gathering samples in the antivirus game is the heart of the matter. It's a subject which is rarely explained or detailed in a research paper, and basically a data mining algorithm need strong statistics, so a big database. So how can we gather lots of samples? Several universities share them freely, like North Carolina State University with the Malgenome project, and the University of Göttingen here in Germany with the Drebin dataset. Also, some websites share Android malware, like VirusShare and ContagioDump. Maybe you have heard of it. It's a good starting point, but not enough. So I researched on how the malware company, antivirus companies get their sample. So my main guess is that they get the sample from client and user submission and inter-company exchange mainly. Here is an Android report when we can see that 70% of their apps they got it's from inter-company exchange, and unknown sample, something labeled as unknown sample, which is in fact user and client submission. So it means you cannot mimic in a laboratory. So I designed a crawler called Tarantula, which gets a sample from wild FTP, torrents, and alternative market mainly. I stopped crawling at 280,000 applications, and yes, it's je schéma for the internal structure of Tarantula, and est-ce que tu peux passer à la suite, s'il te plaît? And the malware discovery with the application I've got is a work in progress. But I hope I will find lots of malware. The last tool I'm going to present you is dynamic analysis one. I called it Panoptes, and it basically monitor almost all communications between an app and internet, even the encrypted one. So at the end of the analysis, it generates a graph of network communication to help detecting some behavior in this mess of information. You will see the graph when I will present the banking application. So I just told you it bypass SSL. As I control the phone, I put a certification, fake certification authorities in the phone, and my phone connects to a fake access point, and basically the SSL requests are intercepted, and the requests the destination server address requests are sent back to the phone, signed by our fake certificate. So the phone actually believes that it is a legit communication.
So At the present time, we have analyzed in detail 27 applications, and of course, we will go on and increasing the results, and everything will be made public little by little. So, as you can see, we have at the beginning analyzed a French bank, but we try to cover all the world, and the next step will be to analyze banks from Asia, because there are a lot of development in banking application. So, before presenting the four illustrative cases we have identified, in fact, I would like to present some statistics which are summarizing what we have found. First, if we have a look to permission, we see that those applications generally are very invasive, and they have a lot of they get a lot of access to many internal data in our smartphone or tablets, which is very worrying because they can eavesdrop many information. But it is probably more interesting if you consider the behaviors. You have here the main behavior that are involved in the application between the smartphone and the server, and two of them are rather interesting. First, here it is possible to identify specifically a phone. But if you consider here this percentage, which is rather high, 96%, are loading dynamically the content of the app from the web. It means that this content can be leaked content, but it can be on purpose and very specifically malicious content. It depends whether you trust your bank or not. And here, the second behavior, which is rather interesting, is this. Many phones are by now vulnerable to the execution or arbitrary JavaScript instructions. So it means that it is possible, by perverting this and exploiting the fact that many phones are still able to, are still vulnerable, but now for the newer version, the number of JavaScript that can be executed is limited, but for older version it is not, and it is possible to remotely execute possible JavaScript, malicious JavaScript. Of course, either if you are on the banks or if you are an attacker. For example, in man-in-the-middle attack, we will see one bank is vulnerable to this kind of attack.
So,
donc tu veux que je te montre le truc?
Let's get started with the demonstration.
The report? Okay.
I will start by JP Morgan Access, which is the mobile banking app of JP Morgan. And here's the graph of network communication I've told you about just before. So there are an interesting JSON file received from JP Morgan servers. We can see there. So the graph shows all the session and summarize all communication for a server address. Okay, and we can also see all strings that the application send to a certain to a host. So it's for finding some data leak, personal data leak. So here we can see just two strings are sent. It's either in the argument of a get method or in a post request. So here the application received a JSON file there, and so here we can see signature. At the beginning, I thought it was a bit long for signature for authentication, for example. So maybe it is an encrypted string. I just after that I used a tool called API Monitor to see if after receiving the string, the app decrypts something. So, ouais, je vais revenir sur PDF. So, ouais, API Monitor, basically it reverses the app and monitor function around Android calls that we configure, and at runtime dump the content of the arguments into the logcat, which is the centralized Android log system. So we can see argument of function we configure dynamically. So, est-ce que tu peux remettre juste avant, s'il te plaît? Voilà. It's not very visible, but sorry for this. Here, trust me, it's the received string signature. It's a little messy there, but it's the string I just showed you before. And this is non, ne passe pas, s'il te plaît. This is a decryption function used, and these ASCII codes are in fact the argument of the decipher function, and here the result value at runtime. So what I did is I copy the return value, and I use some scripting commands to get a readable string. So here we go, the readable string. Voilà. So it's a several string separated by a pattern, and the content of the string are not very important because it's the pattern. With this pattern, we can search in the code, in the reversed code, where this string are used and what the application do. So it's what I did. I cannot show you the code because it's proprietary. So it's just a subset, just to show you what it do. So the string is received, parsed with this pattern, and a part of this string is sent directly into a shell command. I reversed this function, run command. It's not a basic Android function. And if the phone is have root privilege, this command executes the argument as root privilege. So basically, what it means it's a remote shell. So why they did this? Why they at runtime when you launch the app send a command from their website and execute it on your phone? It's a part of a framework that verifies the security of the phone. And a part of this verification is done by sending shell commands to verify if the phone has been infected or so on. But they could have done it differently. For example, loading verification procedure from encrypted assets, for example. But this way of verification lets the phone vulnerable because they can send arbitrary command targeted because the connection are the application sends the IMEI, which identify one particular device. So if they want, they can send arbitrary command at a targeted device. So basically, we have to consider it as a backdoor. The next application is BNP Paribas. It's a French application. So let's see the network communication. So here, we receive an interesting JavaScript code. It's there in clear text. You can see it, HTTP in clear text. And let's get the JavaScript. So we cannot see because there's nothing to see here. So this not seems to be a regular JavaScript function. So maybe this is a JavaScript interface. And JavaScript interface in Android are bad. It grants the JavaScript the right to call defined function of Java application. But in older version of Android, there was a flaw, and the JavaScript could call arbitrary command by reflection. So the JavaScript could get a shell, for example. And there are lots of vulnerable phone in use today. So when they do it in clear text, any man-in-the-middle attacker can control the phone, basically. So it is a major vulnerability.
So BNP has taken this information, is currently trying to correct the vulnerability.
So it is summarized there. The next one is a Russian bank, the Sberbank, and it's an interesting example. Not because it is vulnerable. It's not vulnerable. It leaks some informations, but you will see why it is very interesting. So here, so it uses an API called Yandex Maps API. And let's see what it sends. Wi-Fi networks. And this is the MAC address of my fake access point used for doing network monitoring. So it dumps all surrounding. It maps the Wi-Fi networks, the surrounding Wi-Fi networks. So why they do it? It's I done some research, and it is in fact it is used for find indoor location, and every other operator did this way. Google Maps do it this way too, and it sends also the SSID of all Wi-Fi networks. And when we can see the responses of these calls. So let's try one. No, this is not one. It's a random try, so maybe not the first. Okay. Yeah. So it sends Wi-Fi networks, and the response is phone by Wi-Fi. So they know my Wi-Fi, and they get my location with my Wi-Fi. It means that they have my Wi-Fi MAC address in their database. But how do they have all this information? In fact, when you, for example, Google Maps, all the time they send all surrounding Wi-Fi networks with your last known GSM location, because GSM cannot locate you precisely indoor. So they map your Wi-Fi networks with the last fine GSM location. This way, they populate their database, and so they can locate other users. So basically, they have a database of world Wi-Fi networks. Wonderful. And it's not especially Yandex. It's Google Maps and other companies that does Wi-Fi location. And it's not the end, because they re-implement the Google Map API. They do not use it, Yandex. Your option for disabling the location have just no effect on this application on Sperbank. So we can disable your location. It's track your location. So the last one is Bradesco, a Brazilian bank. In this application is some exchange are sent with this host, web service infomoney.com.br, and an interesting session there. We receive a private key in clear text there. So why? This private key, I just done some quick research. So basically, you take this address, copy.
J'ai pas de connexion internet, attention.
Ah oui, no internet connection. So I can see you, but I will explain you. This private key is for accessing the web service of the bank. Voilà. And this is not over. The application embed a jQuery JavaScript file, the library, but it is very, very outdated from 2010. So there are several vulnerabilities that have been discovered, and they are in the CVE database. I did not find a way to exploit these vulnerabilities, but others surely can do it. It's just what I say. Thank you. Ouais. This is the end of the presentation. I will be pleased to answer your question.
So,
and I will let Eric Fier conclude.
So, in fact, it is only a small sample because 27 apps is a small part of what we intend to cover. But in the forthcoming weeks, many details will be published. In fact, we are waiting either for the answer of the bank or for the correction of the problem. And of course, if the banks do not answer, so we'll have to publish at least in order to make them aware of the problem. So we intend, of course, to analyze other kind of apps because, for example, games are maybe games is less important than banking, of course, but it can leak a lot of data, and we intend to see whether the new, for example, the new version of Angry Bird and so on still contains many non-disable functionalities. Email clients, security tools, because we have some concern about apps who are supposed to protect our phone, but in fact they are leaking information and are making our smartphone or tablet weaker. So, in fact, all those tools are still under development, and we intend to put more mathematics in order, to, for example, to use some advanced techniques in data mining in order to have a better view and understanding of the different relationship between API call or internal functionalities. Of course, for every time a bank will correct the security issue, we will look afterward in order if they correct the security and the user's privacy as well. Because in fact, just switching from HTTP to HTTPS, if you don't correct the vulnerability, is not a solution. So we will be very careful about the respect of the privacy aspect in banking apps. So it is only a small. We are very sorry not to having been able to show all the technical details, but everything will be made public as soon as possible. In fact, it is clear that the banking application market is not a very mature market. And of course, we have found some vulnerabilities, but as main aspect, in fact, the user's privacy is not respected. So banks are collecting a lot of information that they should not collect. And we are not strictly related to the bank account management. So I think that everyone should put a big pressure on developers, and of course, maybe it is maybe a dream, but I think that as users and consumers, we should have we should ask for more security, and especially for regarding privacy and data confidentiality. The main problem was to identify contact in banks. And even for French bank, we are French, it was very, very difficult. And even going through the CERT, Computer Emergency Response Team in the banks, they are not communicating between themselves. So it's very difficult. So what is interesting, all those apps are as well on the Google Play. It means that Google does not perform any security verification. So don't trust applications because they are on the Google Play. There is no verification. I think, however, that Google has the power maybe to enforce some trust policy and to ask for more security. Well, so what's the solution? Once again, if they are available, choose open source apps, but in banking world it's difficult because it's a closed world. And as a main observation, it is maybe better to prefer local or national banks instead of international banks because they try to collect a lot of data. So sorry for the problem of demo, but everything, once again, will be made available as soon as possible. And thank you for your attention.
Thank you very, very much for the insight into this huge ongoing effort. Before taking questions, some practical advice. If there are questions, please line up after the microphones. Some practical advice. You find all the slides and all the links to the websites on the Congress webpage. If you go to the schedule, the Fahrplan, click on the lecture, click on the lecturer's site, you find all the links and even a PDF of all the slides and the links. And it's very well worth a close look and a visit. Now I think we wait half a minute until those who want to leave have left the room. Those of you who want to ask questions, please line up on the microphones.
C'est ta première. C'est la mienne.
C'est pas grave. Tu vois pourquoi les plans B c'est important, d'accord? Croisons un vieux routier. J'ai jamais fonctionné sans plan B. Et heureusement j'avais un plan C, j'avais Windows.
C'est un compte que Windows ait marché quoi, face à du Linux.
les problèmes de reconnaissance vidéo. J'ai tellement fait de conférences que maintenant, si tu veux, ça c'est l'horreur.
Ouais.
Okay. Okay, ask your question.
Hi. You had this one slide regarding which
Please use the microphone.
You had
Very
this
good.
one slide, which apps use which permissions statistics page. And the second point was, I think, that the ability to use plain text communication, use clear text communications, what does it mean exactly? That they could use HTTP, but are configured to use HTTPS, or what does it mean?
If I well understood, why they use HTTP instead of HTTPS? No?
Yeah, or do they use HTTP for sending banking information?
No. When I never seen an banking application connecting to the bank account in HTTP. It's the other functionality, like user tracking, which is a functionality,
Yeah.
and things we have seen, like the private key received. This private key is not used for connecting to your account. It's used for other services. So your money is pretty safe if they not use some backdoor, like in the JP Morgan case.
Okay, but do they check the certificates of this of the server? And there were some lectures last year and the year before on how they all do it wrong and not check the certificates in SSL connections and stuff.
So your question is any app trusting all hosts or something like that, or not doing good SSL?
Yeah, that's pretty much it.
I've seen one application, but it's not an official banking app. It's an app that aggregates. I don't know if it exists in English, but in French it exists. Which aggregates lots of banking accounts when you have multiple accounts. And this app was sending the password with SSL communication that trust all hosts. So there was no security at all. But it's the only one case where I've seen a misconfiguration in SSL.
Okay, yeah. So it's not as bad as it sounded on the slide.
Yeah. But in fact, the apps who are aggregating several banking applications will be probably a problem in the future, because at the present time we're mainly banking apps alone. But those aggregation applications will have to be monitored, because there are only a very few. But the problem will be maybe at that level.
Yeah, but this is a whole different problem, right? If you trust your bank to deliver a secure application, that's one thing. If you trust somebody else to do
the
proper
job,
implementation of all banking APIs, that's gonna be a tough thing. Okay, thank you.
Okay, next question.
After we now got quite a few of very good examples for horrible practices, which was the best app you found? And to directly add on that question, how did the two German bank apps compare?
The best, I don't know if they are a best application, but more generally, I found that, for example, some national bank in France was good, like Société Générale, and some app from India was good, but they are not known at the international level. The Commerzbank in Germany was pretty good, and the Dutch bank was also quite good. So they was not all horrible, if it can reassure you.
Yes, thank you.
There is one problem because there is two different points. You have vulnerability and security issue, but from a more general point of view, you have users' privacy respect. And in this case, banks are maybe less respectful of all data.
Maybe you have not, you don't know the concept of user tracking in websites or if okay, you know. So each time you click on something, the request is sent onto a server and say this user have clicked on this and it stayed x time on this Windows. So it's like all you do is known and is stored, and is there are some statistics and some behaviors, or they can know some behaviors of consumption. It's pretty creepy to me, but.
Thank you. Next question here.
Thanks a lot. First of all, thanks a lot for your work and for presenting it, because it is really interesting. I would like to ask this question. Your program does some reverse engineering of the code, and you are able to browse the reverse engineered code. But how does it behave when the code is obfuscated, for example, with ProGuard, DexGuard, or if the code is developed using NDK or something like that?
The reverse never fail. Okay, but the code can be obfuscated, but when you are trying to understand reversed code, you do not need to understand all it happen. Okay, the main important thing in Android application are Android API call, which is the function that the phone provide to access valuable information. Okay, so if I can see this function, I basically can see what the application can do. Even if there are some junk code here and there, it's not important. And I never seen an application that obfuscates API calls. But it isn't theoretically possible, but I never seen it. Moreover, static analysis, we all know, have limitations on obfuscation. And, well, nobody can beat all obfuscation. It's okay. So it's why we use also dynamic analysis.
In fact, when obfuscation is used, this is poor obfuscation. It means that with the tool, it is possible to bypass the obfuscation. But if someday we will find a very deeply obfuscated application, well, we will do by hand, manually. So, but most of the time, the automatic reversing is sufficient in order to bypass very poor obfuscation that we.
Excuse me. What do you mean with bypass? Because when you obfuscate, you lose some quantity of information.
At least understand the function, some functionalities.
Okay.
But it's at the present time we didn't ever found very obfuscated application.
Sophisticatedly obfuscated. No.
They don't care about protecting the apps.
Mm-hmm. Okay, thanks a lot.
Well, there's another question on the other microphone.
Okay, in the beginning of the talk, you said you used man in the middle to be able to analyze the SSL communication. But this, to me, it means that the applications should have understood they are not talking to the bank and should have just stopped communication at all.
It's a very interesting question because BNP Paribas, with its vulnerability, beat my SSL man in the middle. The vulnerability I've discovered is because of user tracking framework. But I could not connect to their server because they refused my connection. Why? Because I think, I'm not sure at 100%, but 100%, but I think they embed their own list or set of certification authorities, and they do not use the system list. So it basically beat my system.
Okay, but this happened only with BNP Paribas.
Can you repeat, please?
This happened only with one bank. All the others worked?
It happens with maybe 5 of the 27 banks, but it's the banks are more careful, a little more careful on security. So some of the banks implement that trick, but not all apps at all.
Thank you.
More questions? If not, again, you find the slides and the links on the Congress website, and keep an eye on it. Thank you very much, gentlemen, for the useful work.